History rewards the innovator, the pioneer, the trailblazer. For over 30 years, Supermicro has been fueling innovators and visionaries with the industry's best computing resources. We have built the industry's widest portfolio of storage servers with the largest open ecosystem of leading storage hardware so that you can be first. Welcome to Supermicro's 2025 Open Storage Summit.
Hello and welcome to the Supermicro Open Storage Summit. I'm Rob Strechay, Managing Director and Principal Analyst, and today we'll discuss AI inference at scale and the storage considerations. As enterprises continue their AI journeys, a fundamental shift is taking place, one that moves the focus from training massive models to efficiently running them in production. That shift, it's all about inference and the need to scale it effectively. Inference isn't just about serving a single model, it's about running thousands or millions of model-driven decisions in real time across edge, data center, and cloud environments. And behind every low latency response is a silent workhorse, the storage infrastructure. Unlike training pipelines, inference workloads rely heavily on high volume, high variety, unstructured data. This includes logs, images, video frames, sensor outputs, and much, much more. Often stored as file and object data. Feeding that data into GPU-centric compute environments at scale demands storage solutions that are flexible, high throughput, tightly integrated. This is why new storage protocols and data services are so important to be deployed. They enable efficient access to unstructured data across distributed inference frameworks, reducing bottlenecks and unlocking real-time performance at scale. We're also seeing the rise of tiered storage architectures where performance, capacity, and costs are intelligently balanced to keep inference flowing without over-provisioning. Object storage brings massive scalability and durability, while parallel file systems ensure low latency access for performance-critical workloads. Organizations are looking for the easy button for deploying validated GPU-optimized infrastructure with integrated solutions built around these emerging data pipelines. And it's clear that storage isn't just an afterthought. In this session, you'll hear directly from leaders building this next generation of inference infrastructure and learn how to scale your unstructured data pipeline to match that speed of AI. So let's get started. Joining me is Harish Arora from NVIDIA. Then I have Tony Asaro, who's from Hammerspace, welcome on, and Peter Sjoberg from Cloudian, Ace Streicher from Solidigm, and last but not least is Tien Lee from Supermicro. Welcome on board, everybody.
Thank you, Rob.
Thank you.
So I think to kick things off, let's kind of get a baseline for where everybody is with inference and at scale. Why not kick it off with NVIDIA? Harish, why don't you start us off here?
Thank you, Rob. And thank you, Supermicro, for this excellent opportunity to come and present at Storage Summit. Thank you, Cube, for hosting this conference as well. My name is Harish Arora. I work in the DGX product management team. I'm responsible for managing the storage programs for the group. I am really excited to talk to you about AI factories and the new definition of AI factories, the expanded role of AI factories that we see here. Earlier AI factories used to focus primarily on training. Customers would deploy all of their infrastructure primarily for training of foundational models, fine-tuning them, and deploying them elsewhere. But now the expanded use of AI factories includes production serving as in inference and data prep as well. So we are excited about two broad categories of technologies that we have introduced to the market, to our partners and to customers to enable inference at scale. First category is a set of services which we call NeMo Retriever services. They are focused on generating insights and connecting the LLMs, the GenAI engines with enterprise data. The second category is about a set of technologies that are used to scale up and scale out generative AI using disaggregated inference. We'll dive into both. So let's look at what NeMo Retriever is. Enterprise data, especially the unstructured enterprise data, is expected to grow from 14 zettabytes all the way up to 30 zettabytes by 2028. Majority of it will be in the form of documents and unstructured, video data, images, log files, what have you. And the data captured inside, data kept inside enterprise data files is actually quite complex. It includes multiple file types and multiple modalities of data inside those files. Those files can include images, charts, diagrams, text. So extracting intelligence out of all those files, trillions of files, and having them be used to generate insights is actually a very complex process. NVIDIA has introduced a set of technologies under the name NeMo Retriever to accelerate via GPUs all the processing that needs to happen on all the data that to be used as context data for LLMs and for video language models. These NeMo Retriever services are actually NIMs, and NIM stands for NVIDIA Inference Microservice, easy to use in a cloud native architecture. These NIMs collectively extract all the data from the various enterprise data files and generate the embeddings and keep the embeddings or store the embeddings in a vector database. Further re-ranking, further optimization generates better results, so that whenever any GenAI application wants to query the data, they are able to search the right context or extract the right context from your enterprise data and generate contextualized, meaningful insight for you. Storage has a big role to play in this entire RAG pipeline. I encourage all viewers and partners to visit build.nvidia.com to learn more about NeMo Retriever. On storage, the vector database ingestion of all the embeddings and index creation is very storage centric operation, and it requires high performance storage, which is where high performance file access, high performance object access becomes all the more important. And on the point of AI factories, we are working with several high performance object storage providers to expand the customer choice beyond just parallel file systems, beyond just NFS file systems, to include high performance objects as a great foundation for AI factory. There are set of challenges that we have seen emerge in the past few years, especially as the models have increased in size. I remember the time when BERT was introduced in 2018. The state of the art models available today are several thousand times bigger than what was introduced in 2018. We see many reasoning agents being introduced and used in the GenAI applications. Those reasoning agents themselves generate 100 times more reasoning tokens, thinking tokens between themselves to accomplish various tasks. And the models themselves are now enabled to take in much larger context. Llama, when it was open sourced or introduced, the first generation of models was limited to few thousand tokens. But today, the state of the art Llama 4 models can take up to 10 million tokens as their large context. All of this increases the complexity of deployment. All of this requires better infrastructure and better management of the models. There is ample research in academia, ample research by other companies, and ample research inside NVIDIA that has led us to introduce NVIDIA Dynamo as NVIDIA recommended solution for disaggregated inference to help scale and serve generative AI. We'll talk more about Dynamo architecture. Dynamo architecture is very modular. It is open source, so you can use any part of Dynamo as you see fit. It includes KV Cache Manager that manages a KV cache state across a set of memory hierarchies, whether you are keeping the KV cache state in the GPU memory, in the system memory, on the local storage, or even on network storage. And it manages the caching policies very intelligently by keeping the most frequently used KV cache, KV states in the GPU memory and offloading less frequently used KV cache state onto storage. It uses NIXL. We introduced another library called NIXL, which stands for NVIDIA Inference Transfer Library. This transfer library helps the KV Cache Manager move the KV cache state across different memory hierarchies. And we encourage all storage partners to develop custom backends to integrate with NIXL. NIXL is also open source, so reach out. We are happy to help you on that.
Great. So let's now swap over to Tony, and Tony, kind of help us understand Hammerspace and how you play in this space for inference.
Certainly. So Hammerspace is a software company. We are a rapidly emerging leader as an AI data platform. And if I may say, we are creating a cognitive leap that's disrupting the status quo. Our customers are using Hammerspace instead of legacy storage. So our superpowers include a standard-based parallel file system. So we support NFS 4.2, but we also support S3 because we do see the emergence of that with our customers. But everything runs on a high-performance parallel file system. We treat objects as files, and we can do all of these great things, data services that go along with that. We have multi-site data access, so your distributed data, we can get it to your GPU resources regardless of where they're globally located. We're very ecosystem friendly, so everything Harish just talked about, integrating with their stack is something that's very programmable within the Hammerspace data platform, and that's what data platforms are all about, right, is working with an ecosystem. So we're working with best-in-class solutions, third-party solutions, as a part of our data platform, both at a software and at a solutions level, systems level, which SMC is a strategic partner of ours from that perspective. Our customers are hyperscalers, so Meta is using us for both training and for inferencing. We also are working with neoclouds, and we're focused on enterprise customers because that's where the next wave of massive growth is happening with AI. So we have this concept called AI Anywhere, which we'll talk about. So the idea is, is that your data is distributed. And what Hammerspace has done is that we have eliminated data gravity. Now, that's not hyperbole. We actually do that. What we do importantly is that we make sure we do it with by untethering the data from the physical layer. We make sure we do that with a high degree of intelligence, right? Control, security, and specificity, meaning that we have file granular control over your data where it's orchestrated, right? And where you want to move it, get the data where you need it, when you need it. So that's important. And we are able to basically use your infrastructure. So if you've got data that's on 20 different storage systems, if you want to leverage the storage inside of your GPU servers as part of a high performance tier, you're going to get the fastest performance from that. If your data is distributed across 6 different locations around the globe, if your GPUs are in your data centers and you want to be able to burst to the cloud or the neoclouds in order to augment your GPU servers that you have on-prem, if you've got a deluge of data for training or an irrigation system for inference, right, that's the concept of AI Anywhere, and that's what Hammerspace enables. Now, data has an expansive life cycle, right? We often, it's a football field, and we often talk about the last yard and how fast we can get into the end zone, right? But we have to go to the other side, right? And there's a lot of ground to cover to get to your goal. And that's where Hammerspace stands alone. So taking a look at your AI pipelines from ingest to preparation through that whole process, right? Hammerspace can orchestrate and assimilate that data, instantly getting the data to your GPU servers for inferencing and other workloads. So the idea is, instead of doing these manual processes of staging and destaging, we can automate those pipelines through orchestration and through assimilation. So if you think about it, right, you have to consider the entire life cycle, right? If it's a relay race, it doesn't matter how fast your last runner is, but the entire set of runners in there in order to get that performance. So data is in constant motion, and the key is determining whether you want to go through a convoluted and complex maze that you need to navigate, which is slow and painful, or whether you want to do it through a mapped out, well-defined path. Now, it's a different way of thinking, but those who get it really get it. So I will hand it over to Peter, from my colleague at Cloudian.
Peter, yeah, help us understand kind of where Cloudian and objects fit in with this. I think we got a good perspective, but I think, where Cloudian is in this entire inference.
Sure, thanks, Rob. Cloudian's an object storage vendor installed in thousands of sites worldwide. Our focus is really on taking data from any source and allowing it to be stored for any need. Now, historically, object storage has had a focus on areas like long-term retention of data, protection of data, and now we're starting to see how we can optimize this capability for AI workloads and serving some of the needs that we're talking about here. Our focus is on our partnership with NVIDIA, bringing out what we see now as I think a change in the space, which is NVIDIA's GPU Direct for object storage. This has sort of recently come about, and the idea is to get a direct parallel path from the storage into the GPU memory. In doing so, we're able to accelerate the access to that data while still using object storage. And that's an area a lot of folks are not familiar with or may not expect. And we've been able to put up performance results, you can see them here, over 200 gigabytes per second in a 6-node system. And while we're doing that, we're also able to offload the traditional CPU burden. So our goal is not just to be an object provider, but to be an object provider for an AI data platform. Now, I think it's important to note, both Harish and Tony mentioned, the adherence to the S3 API. S3's conversation in API land is really a standard now, and we are extremely adhered 100% to that S3 API. So any applications that you're using or writing, be it in the cloud or on premises, are able to leverage that exact same, in fact, we'd argue, use the same software development kit and build that out against your object platform in order to achieve these types of performance capabilities. We're looking to see this become part of the AI or the S3 API standard, and we think that's really going to transform how people can use object storage. Now, that performance gives us a chance to look at some of the things that Harish was talking about, which is putting these NeMo modules, the retriever modules, directly embedded in a storage platform. Now, the idea here is these are going to be accelerated capabilities, these microservices capabilities, accelerated where data resides. And we see object storage as a platform that serves so many of the different AI workloads that putting these capabilities into the platform directly, in our case Hyperstore, this can serve both the extraction capabilities and needs of AI as well as the retrieval capabilities. And of course, when we talk about inference at scale, our focus for today, we want to be able to see that performance scaling to meet those needs long term as customers grow their inference capabilities. We call this a Cloudian data-centric AI platform. And if you think about the 4 key stages of a workflow, the ingestion of your data, that raw data that we talked about coming in from all kinds of sources, largely unstructured, be it servers, be it sensors, be it the cloud, storing that locally is a great first step. Now, being able to produce that for processing using things like the NeMo retriever capability, and of course, preserving it for long-term use. All of that is to prepare for the consumers that are going to extract that, whether that's training, fine-tuning, or, of course, this inference that we're focused on today. So that's where we see ourselves.
That's great. And I think, again, all of this together, and we'll go to Ace and kind of get Saadim's view on the world here as well from an inference perspective, but I think that it's bringing this all together to make it simple for organizations, performant, and cost effective, because I think that's in everybody's mind as well. So Ace, why don't you take us here and give us an idea?
Absolutely. Thanks, Rob. I'm with Solidigm, and we make SSDs, which sounds relatively straightforward compared to some of the very clever solutions of my esteemed panelists, fellow panelists here. But
I think you're underselling yourself here a little bit, though.
And overselling SSD.
what it does mean is, we have teams of engineers in the lab battling the laws of physics daily to try to figure out how to develop more capable NAND with higher performance, higher endurance, right? Greater power efficiency, the kind of stuff that our customers tell us they care about. And then those things go and get plugged into and sort of enable the excellent solutions that others have already discussed. The name may be unfamiliar to some out there. The company's relatively young. We're about 3.5 years old, but much longer heritage than that. We are owned by SK Hynix, and born out of that company's acquisition of Intel's memory group back in 2021. And so myself and many of my coworkers have been in the industry for a while wearing different badges over time, right? These days, we're very, very focused on AI because it's an incredible driver of data magnitude globally. And all that data's got to go somewhere, right? We like to say there's no AI without data, there's no data without infrastructure. And I might add to that, there's no infrastructure without efficiency, right? Because we continue to hear that there's these really scary power forecasts out there, and data center space is limited. There's cooling challenges, right? There's a lot of things that go into building an efficient data center, and folks may not realize that storage can account for a lot of that space and a lot of that power consumption if it's not optimized, right? If you're using legacy storage, there's probably a lot of room for improvement, and that's where products like these Solidigm ones on the slide come in. So we have a whole product family, but looking at AI, this is a good representation of a couple of products that our customers are adopting for the two places in an AI cluster where we see storage really showing up. So on the left, in the direct attached storage space, that's inside of the GPU servers, like the DGX boxes that Harish talked about. That's really where we see the high performance SSDs slotting in. Those tend to be PCIe Gen 5 moving to 6, tend to be built on TLC NAND, 3 bits per cell. That's high performance media. And really the ability of those drives to keep GPUs fed and keep them humming along at maximum utilization, all the things that Hammerspace is really good at supporting, right? And the reason their revenue 10x last year. Congratulations, by the way. And then on the other side of the product family, we have the high-density QLC 4-bit per cell stuff. Tends to be PCIe Gen 4 today. And that's really about efficiency and density, right? So in a single drive, like the one I'm showing there on the right that's about the size of a deck of cards, you can fit 122 terabytes and growing, right? And what that means is fewer drives to do what you need. Fewer drives means less space, means less power, means less cooling, all the good stuff. And it brings all sorts of efficiency gains and benefits of the type that Cloudian and their HyperStore approach is really good at delivering as well. And so I feel like there's pretty good alignment here among the panelists as far as what we're trying to accomplish here in the world of AI. I want to speak just briefly about why storage matters in inference and maybe tee this up for a little bit of further discussion later on. But it's one thing to say better SSDs probably lead to better AI outcomes. That's true, right? But how does that actually show up specifically? It comes down to an understanding of the interaction between memory and storage in the course of running an AI workload. And this is something we've spent a lot of time and a lot of calories on at Solidigm, is running AI workloads, characterizing them, understanding the I/O characteristics, and building solutions that can kind of optimize where that data lives and making sure it's ready when it needs to be accessed, right? So there's a couple of approaches on the left side of the slide that I would call mainstream. Data ingest and archive really has to do with, okay, if you're pulling inputs for your inference pipeline from SSDs, make sure they're ready to go, right? And make sure you can get that stuff fast enough. And then on the other side of that coin, make sure you can store it efficiently at the end of the pipeline, all your outputs and so forth. RAG scaling is another big area. Enterprises are rushing to adopt RAG at a really high rate. They love the ability to pull in additional data that the model wasn't originally trained on, get better, higher quality answers to their questions, right? But all of that can get very, very quickly expensive if you're storing all that RAG data in memory, right? And so there are approaches now to offload some of that from memory to SSDs and sort of turn those dials and achieve better TCO aligned with your specific application or the problem you're trying to solve as a business. And on the right-hand side, a couple that I'll call out as emerging. Harish already talked about KV cache offload and the great exciting possibilities that Dynamo offers. We're watching that closely and playing around with that ourselves in the lab. It's a very exciting space, a lot of activity, as well as model weight offload. So there are techniques you can use to actually move. You don't need your entire model in memory at any one specific time. You only need part of it, right? So you can store the rest of it in disk, and what that unlocks for you is the ability to run complex models on GPUs that you may not have been able to otherwise, that have less onboard memory, right? And so these are a few of the ways that high-performance storage is showing up and working with memory to deliver better outcomes and new possibilities in inference.
Now, I think that totally makes sense, and we'll bring Tien in here as well, but to me, it's about how do you do more within the constrained space, and I think SSDs absolutely hit the bill from multiple different angles, as you were talking about in there. So Tien, why don't you bring us home on this portion of this and help us understand, where does Supermicro come in on this whole thing?
Yeah, thank you, Rob, and very thankful for all the partners joining us today and sharing all the deep insight and excellent technology that's coming down the road. I think it's fair to say that Supermicro's role, my job here is to share with us how Supermicro ties all these technology together as a complete solution. Because at the end of the day, any organization that's looking to capitalize on inferencing at scale, we need a complete solution. You will not get success by just having one piece, only one piece that works, right? So it's always about a total integrated solution. So I'd like to kind of talk through this, showing how Supermicro is the #1 partner that any organization should really consider. I demonstrate this by talking through the Supermicro timeline, and I think at the end you'll see why this is relevant. Supermicro always has this DNA of integrating and partnership and thinking about solution as a whole. Because we started our journey early days building motherboards, and as you can imagine, motherboards, it's only at a component level most people think about today, but it's really meant to serve at a solution. So fast forward, we did motherboard really well through excellent engineering and also understanding our quality comes through by integration and really delivering the solution at the end of the day, right? So we have migrated that business onto a server level, building servers really well, and fast forward to recent years, the AI boom really has delivered the unprecedented challenges in data center scale, as well as these massive scales of needs of equipment and other challenges that come along with it. Let me dive in a little bit deeper here on what I mean by total integrated solution, right? So traditionally, everybody think of a technology stack as on the top, you have the networking, and then there's racks of servers that are connected together, and then and the core component system level. But what this really is not telling the whole story. There is the whole slew of other challenges and services and integration technology and effort that must be considered in parallel with this. So what I show on the left-hand side is what Supermicro has experienced, as well as services that's ready to offer and help customer really tackle the whole entire stack as a complete solution.
Absolutely, and I think that's a great lead-in to where we're going next. So I think, you know, Harish, we'll start off with you, and I think, again, when you start to look at NVIDIA and working across the entire storage infrastructure, you have a lot of partners. I mean, you're NVIDIA, right? I mean, everybody knows NVIDIA, and you have a lot of customers, and you see a lot of different things. How are you seeing NVIDIA working across the storage industry in general?
Absolutely. No, that's a great question. Thank you. NVIDIA has always taken the approach that ecosystem is what makes us stronger. We help our partners succeed, and that's how we succeed. And we apply the same approach to our storage partners. And we work very closely with all the industry leaders, including the new and emerging companies, on two different ways. One is we have very well defined certification programs for different market segments. So there is a DGX certification program for all the DGX SuperPods and BasePod line of products. Then we have NeoCloud certification program, which we call it as NCP, which is targeted for NeoCloud practitioners who want to deploy infrastructure at a very large scale. We also have NVIDIA certified storage program that is targeted towards OEM server and storage partners. And we are very glad to have Supermicro as a key partner in that program. So certification programs is one way in which we work very closely with storage partners. The other way is, as we develop technologies and as we identify integration opportunities for storage partners, we are very happy to present all the emerging technologies inside NVIDIA to all the storage partners, even as the technologies are being developed. So we don't wait for technology to be fully developed and matured. We are happy to engage with the storage ecosystem as early as possible, so that they can start integrating with NVIDIA technologies and they can start developing solutions and offer higher value products and solutions to their customers.
No, I think that is totally key, and I think I loved where you were talking about the open source and how you're bringing people in, and everybody's talking about things like NeMo and NIMS and Dynamo. And I think, again, let's jump to ACE, because I think, again, one of the things that when I look at this is that, and you mentioned it, was feeding the GPUs and really keeping high performance storage to really do that. When you look at offloading inference and how that really moves from memory, we kind of hit on it a little bit, but let's kind of dive a little bit deeper in there and look at really what you meant by that, because I think that's really key and critical as people look at their entire architecture of what they're buying from an AI perspective and inference in general.
Sure. Yeah, it's a space where there's a lot of active innovation, some really exciting work going on here. And essentially what we're observing is it's difficult and often impossible at this point with the explosion of RAG data that we've talked about, with the more complex models, to stick everything in memory. Of course we would if we could, right? But economically and technically there are real challenges to that. And so the question becomes, how do you design a system where the components work together to deliver better outcomes and solve some of those economic and technical problems? And so we've done some work, and you can read about it if you'd like on our website. We've posted it all on GitHub as well if folks want to try it out. But essentially what we started with was the question of, in an inference pipeline, how much data can we move to storage, and what would the benefits be of doing that, right? And so we ended up with an approach that is built primarily on open source components. Anybody can take it and run with it. But it does two things. It moves some of the model weights from memory into storage. In the white paper, for example, you can read about us running a Llama 70 billion parameter model on an L40S, which is not possible without that kind of SSD offload, right? That's a combination of model and GPU that doesn't work unless you move some of that data to storage. And then the other thing that we did was move some of the RAG data from memory to storage. So when you are generating those embeddings and you populate a vector database, you're also building an index. And we're able to use a Microsoft technology called DiskANN to move the vector data index to storage as well. And so what we observed when we did that was a couple of cool things. One was you're obviously using a lot less DRAM, which is the goal of the exercise to begin with. And in some of our tests on a 100 million vector data set, we saw about 57% less DRAM being used when you're offloading stuff to disk in that way. We also, kind of counterintuitively and surprisingly to us, observed better performance when you offloaded some of that RAG data to storage. Typically, you think when you move anything from storage or from memory to storage, you're losing performance, right? That's the trade-off. But what we found was that the indexing algorithm that's used by this disk ANN approach is so efficient that not only did we maintain performance when we moved data from memory to storage, we actually gained performance in some cases. Net, that results in not just a queries per second increase, but a queries per second per dollar increase as well, right? Which is really the bottom line in the language that our customers are speaking. So like I say, encourage folks to check that out if that's interesting. We have a demo that involves a traffic safety use case, and you're uploading a video of an intersection, and then you can kind of watch the pipeline as it goes through. Model number 1 is a vision language model, generates text summaries of each video frame. Model 2 creates the embeddings and populates the RAG database. Model 3 is the one that actually generates the report at the end, and you get a report that talks about here's what's happening in the intersection, here's the unsafe stuff, here's the recommendations to improve safety, right? And all of that, there's a switch you can flip on the dashboard that we've built to do that in memory or do that in storage, and kind of watch the results and see for yourself. So please do check it out.
Yeah, no, I think to me that is one of the things is around that balance, and it's a balance of performance, efficiency at scale, because like you said, 70 billion parameters. As you go towards inference, you may be using small language models, large language models, multiple models as we get towards agentic and things of that nature. But kind of going back to, you got to feed everything. Tony, Hammerspace really has, grown really precipitously. You're going up against some big players in the file space.
Sure.
Kind of help us understand a little bit about how Hammerspace is winning and where kind of Supermicro fits in the future as well.
Oh, absolutely. So a few things. Number one is that we do have this high performance, massively and easily scalable file system. And a lot of our customers want standards based, right? So leveraging the standards base is extremely important. But really when it comes down to it, it is that AI anywhere, right? So that we've got distributed data. They want to take advantage of our multi-site, our global namespace. They want to take advantage of our data orchestration. They want to take advantage of the fact that we do hybrid cloud, right? Because pretty much all of our customers have some hybrid cloud model, right? And that's critically important. They want multi-protocol environments, so supporting NFS, even SMB, because a lot of data sources are still SMB. S3, we can actually extract data and assimilate data from things like Dropbox and OneDrive and things of that nature as well. So it's really being able to get all of that data and not have to manually stage and destage it, and then automate the AI pipelines, right? That's key, and with a level of intelligence about the data. Right? Not all data is created equally. We want some contextual idea of what that data is in our pipeline. So those are the reasons why. So it's not a me too. There's a lot of capability and intelligence in there. And so that's why we're winning. So we are software defined. And while that's a good thing, it is also sometimes difficult for our customers because they want total solutions. So we're partnering with SMC as a total solutions provider, working with us so that we can provide turnkey systems for our customers. What we love about Supermicro as well is the fact that they are associated with AI. They are in practically every single AI opportunity that's out there. They understand it, they know it, they have a reputation in it. And so working with them just accelerates our access to the market place. So it's been a great partnership.
Yeah, I can understand that. I think, again, people want that easy button when they go in. And definitely you do stuff that in the parallel file system, like you said, being standards-based at the Linux side of things makes things even easier for organizations as well. Let's shift a little bit to object. Not a far jump here, but Peter, you and I, we both worked for another large company that did some object as well. But why is object really a core to AI going forward? And really, when you look at it, you're not a hardware company, but you're really a software company as well. And so how does that play with everything else that's going on in here?
Sure. So I think the biggest question people ask about why object fits in this space comes around with the fact that object is where the data is. Everybody understands how important the data is to serving your AI workloads, whether that's the processing and extraction, whether that's serving training or inference. And one of the biggest issues people run into is they need access to that data of all kinds, including the raw data that's being ingested. So raw data storage, as I said, video streams, sensor data, you name it, document type, unstructured data, all belongs and resides today in object storage. So it's a great fit to be the beginning of where you're going to serve your AI workloads. And of course, these processes now that we're putting into the workloads, such as extracting the value that Harish talked about, or serving training, are all really, really important when we get out to inference. Now that we've enabled object storage to perform in a way it wasn't able to, let's say 5 years ago, in a way that it really isn't able to in the cloud properly, this on-premises system has the ability to serve AI at scale. Now, the thing I always think about in these solutions for AI is it's easy to say you can solve a problem. It's hard because everything breaks at scale. And that scale question is very relative. But the idea is we're a software company. We're designed to spread our knowledge and capability across multiple platforms. Of course, using the Supermicro server environment is incredibly important for us so that as these systems scale, we're able to meet the storage needs of these workloads, obviously. But increasingly, we need technology like Solidigm, where we need the I/O capability to serve out these interactions for the performance. So while we're software-based, we're very dependent on the hardware. And we look to partner with the companies that you're seeing here in order to produce an offering that AI can use across all the different capabilities within object storage.
Yeah, I totally agree. I think when you look at data and you look at a medallion strategy from bronze to gold and things of that nature, you're using the data in different ways across that entire continuum, especially for AI. But it's all got to come together. Tien, when you look at this, you got a great ecosystem here. How do you look at this and say, hey, this is how I'm bringing all of these solutions together for customers? And what are some of the considerations organizations should think about as they're going down the AI path and their AI journey?
Thanks, Rob. That's a great question. So I think I picked up a few things that you said there as key points, right? And even many of our speakers here has brought up, which is the concept of partnership. Partnership brings together an integration and solution. So Supermicro is really at the center of bringing all these partnerships and partners together to build an integrated solution. So on the slide, we can see that this is an example of just a typical AI infrastructure. We could scale this up. So we can see there are your run-of-the-mill typical consideration, right? You have your networking stack connected to various stacks and racks of various type of servers. But some example of integration here is that we have to understand there are technology separations of things like application tier or the GPU tier, and how that really needs to leverage the high-speed networking to talk to something that's extremely fast and high-performance storage tier. And we could even also consider a capacity tier of storage that's connected in a separate network. So these are some of the things that Supermicro has been working on, and we really want to remind any enterprise or any viewer that's considering in their AI inferencing at scale to really step back and really think about the whole ecosystem to design it right so you don't end up spending or overspend on re-architecting, and you will have efficient data flowing through the entire pipeline, which is ultimately the need of inferencing at scale.
Yeah, I think to me that is one of the keys to this all. And let me pose kind of a group question here to everybody. So we'll kind of come to you first, Harish. Sure. So get prepared here. Agents are all the rage. This is the year of agents. Everybody's talking agent this, agent that. But it's really built on the back of inference in many cases and many other types of AI as well. What do you see that organizations should really be getting prepared for as they go down the agentic path, really for, one of the building blocks is inference and getting that right. What are some of the things that you would suggest to customers?
That's a great question, and I think I'm glad that you started with me. This is exactly what was on NVIDIA's mind broadly on what the expanded role for a new AI factory would be. And so as you look at what makes up an AI factory, it's high performance compute, high performance network, high performance storage, all well put together, well tested, well integrated in collaboration with our leading partners on the panel here, so that a common foundation, a common AI factory can run any form of workloads, whether it's production inference workloads with multiple agents running on the same AI factory, whether it's large scale training jobs running on that same AI factory. And if you look at NVIDIA's acquisitions, that also gives you a good hint as when it comes to software infrastructure to manage all this AI factory and the complex infrastructure, look at RunAI as a great workload management suite of technologies that allows you to run different types of workloads on the same infrastructure, whether it's training workloads, whether it's data prep workloads, or inference workloads. So yeah, go learn more about RunAI and go learn more about AI factories, and you'll see that these are great platforms and great software foundations to build your AI factory on.
Great. I'm going to come to you, Peter, because I'm going to mix it up a little bit here. But so, same question. What are some of the things that you would suggest to organizations as they get their ducks in a row around inference as they go down the agentic path?
I think it's important to wrap your mind around what does agentic AI mean, right? This is a goal-oriented solution, and there are likely to be several reasoning steps in this process. There's several LLMs that you may tap into. Now, what you also will recognize is there's going to be several data sets, several different iterations of information, whether it's custom or proprietary documentation at a company, or whether it's integrating with other elements of your data sets or databases. All of those are separately stored and separately needed in things like a bucket. That is a great place to locate that information so that your agentic reasoning model can access the data that it's going to need. And in my mind, you have to be prepared to serve a variety of different data types. We're living in a multimodal data world throughout the process. In particular, as you're building agentic AI, you may not know, oh, I need access to that data set. But if that data set is present, it is available, it's in a bucket, let's say an object store, it's very well oriented to serve your needs going forward. And in my mind, it gives you an AI-ready place to start as you enter this agentic phase.
Yeah, I agree. And Tony, let's go next with you. Again, what do you see, and how is Hammerspace thinking about getting people ready for that movement towards agentic?
Well, I'm glad you let both of them go first, because I concur with it, right? Yeah. So this whole notion of integrating, right? This is what a data platform does. It's calling a storage system a data platform is often lip service, but the ability to integrate with higher level things on the stack, the applications, the tools, through the coordination and the reasoning of that data in these workflows, going to these sets of resources versus these sets of resources throughout the entire pipeline, automating that, having context with that, that's what's critical. In Hammerspace, with our data orchestration, with the ability to put it on your highest performance storage, tier 0 being able to get the highest performance, tier 1 where they need to take advantage of infrastructure they already have. Talk about reducing power consumption, using having no external storage. Oftentimes, just using the GPU storage will not increase your power envelope. But making all of those decisions through that entire process that is that flows through the infrastructure, that integrates with the higher layer stack, that has intelligence at the data layer, is where Hammerspace is, and what Hammerspace is focusing on in this agentic model, and whether that is generative, agentic, whether it's physical, AI, all of that plays a role into that orchestration layer and what we're doing with data pipelines.
Yeah, I totally agree. I think, you know, and Ace, we're coming to you because I think the data has to land somewhere, right? At some point in time, it just doesn't fly around, and you know, it has to be cached or stored somewhere. Where do you see, and what are recommendations that you see for customers as they go down this journey towards agentic from an inference perspective?
When I think about agentic AI, a quote comes to mind. Sam Altman, head of OpenAI, was on a podcast a few months ago and said, AI is hard and energy is the hardest part, right? There's a lot of things about AI that are hard, but energy consumption is certainly top of mind for a lot of folks. And I would add to that quote, as we look toward a future of agentic AI, it's not going to get any easier, right? Because the reality of what's happening under the hood in an agentic workflow is you may have one human-generated prompt at the start of this thing that AI agents very quickly turn into hundreds or thousands of incremental prompts in the course of doing their work, right? That generates a lot of incremental data, a lot more tokens to be processed, right? And so the capabilities of AI agents are incredible, right? And the possibilities they offer are really exciting. It's also going to take a lot of resources to support that, and it's going to become super important to do that as efficiently as possible. Where is this even harder is at the edge, right? We love the idea conceptually, I think all of us do, of moving your compute closer to your sources of data. There's a million good reasons to do that in terms of latency and security and all sorts of other stuff. But you know, the reality is a lot of times you have constraints at the edge that didn't exist in the core data center, right? And so building the next generation of storage with higher performance, higher endurance, and in particular higher density that allows you to use fewer drives, allows you to save on a lot of space and power and stuff. Pairing that with the best software on the planet, which is well represented on this panel, right, is really going to be critical to assuring that we can be as effective as possible and scale agentic AI in the ways that we want to.
Yeah, I totally agree. I think you know, it's not your grandfather's storage anymore, for that matter. So Tien, great reference architectures that you talked about, but bring us home on really what should customers think about, because you're really the easy button for them when it comes to inference and agentic and going down that path. So what are you suggesting?
Yeah, thanks, Rob. So in the agentic world that we're moving towards, obviously a lot of people think about all the edge stuff, all the complexity that comes with it. So my best advice for anyone going down this path is really just step back, right? Understand integration, understand these various technology, all their strength, and how do we get any type of synergy to combine with even more benefits, and how do we architect, how do we design this whole thing? Think about the data flow, and think about how do we not lose that data velocity, right? Because at the end of the day, I think AI requires not only thinking at a holistic level, but also how do we leverage the benefit of it in order to make our lives better?
Yeah, I totally agree. I think this has been fantastic. I think, again, when we start to look across here, inference is really the backbone, one of the backbones that these agents are going to be built on, and getting that right and laying that architecture out like, you know, the foundation of a house. You want it to be solid. You know, guys, I think you gave a lot of things for people to consider. So thank you for coming on board today.
Thanks,
Rob.
Thank you. Thank you, Rob.
And thank you for watching this episode. We'll be back with more from the Supermicro Open Storage Summit. Stay tuned.